So hi peeps, for this video it's one sample t-test. Again, as usual, I'll try to keep it as short, as precise as possible. I'll try to make it as simple as possible. I'll break it down so that you can easily understand what it is. So let's just start. Yeah, so first thing first, you have to remember this table. You should know the difference between population sample. I hope by now you all would. And if not, just go through it. So these are the notations that we would be using in every single problem that we're solving, every single concept in quantitative techniques. So just remember all of these. This is the first thing. Next, you would have watched a z-test video by now. If not, I would urge you to go and watch it. So people get confused between when to use z-test and when to use t-tests. And in real life, there are like various applications, but for what our course is right now concerned with, just remember this table. Whenever you're given a large sample with population standard deviation known, you go for z-test. Apart from that, just go for t-test. It works. So that is what we'll be doing in this course. Remember this, for large sample and standard deviation of the population known, you go for z-test. Apart from that, it's all t-test. Remember this. So next, t-test, we know that there are a lot of varieties in t-test, so we have to kind of decide which one to use where. So for this one, for this video, I would be just explaining the leftmost branch, which is the one sample t-test. Just I would be going in that branch. The two sample is for a different thing. So first we'll start with one sample first. So before that, we need to have an idea of what degree of freedom is. It's a very basic concept, but yeah, it's nothing rocket science. So first we assume that there are three numbers to add and the sum should be 5. Now I can, what I can do is I can put any number as the first number. I can put 10 randomly, 10. And even for the second number, I can put anything. So I'm just going with -7. So if I add both of them, I would get 3. Now I'm constrained here. I have to put 2 in this place for me to get 5. So this is what it says. Degree of freedom is, I can say that 2 numbers are free here and 1 is not free. So there are a total of 3 numbers and 2 numbers are free while 1 is not. So the degree of freedom is usually n-1. And it's the same in case of an average also. So it's the same in case of sum and hence the average. So this is what degree of freedom is. How many numbers are free? Okay. So we'll move on. What is our aim when we are doing a t-test? Okay. So this is roughly like the most simple way you can say it. You have to find the borders. You have to find out R value. What value do I want? And you have to find out if that value lies within the border. Okay. And if it's within the border, you say that it's a success. I accept it. And if it's not, if it goes outside the border, then you say that it's a failure. I don't accept it. I reject it. Okay. So that is what you aim to do in a t-test. Now, let's just get into what the border is. What is this entire thing? Okay. So I'll break it down. In the previous slide, I had written 3 stuffs. Find out the border and find out the value and find out the point. So we just go in the reverse order. Now, if we start with the points inside the border or not, so how do you kind of define it? So that is what is meant by hypothesis. If I say for null hypothesis, the H0 is null hypothesis. So it's something that, okay, I think it's true right now. For let's just assume that I think something is true. So I will call that kind of thing a null hypothesis. Okay. And if I have doubts, okay, so what if it's not true? What if some other thing is true? But so usually what I'm saying is true will be exactly opposite to what I feel might be true. So I'm trying to contradict that. You get it right? So if I say that the average would be 5, I think average is 5. Then I have to test if average is not 5. So this is null hypothesis and alternate hypothesis. Raghu would have explained it in the previous video. I'm just breaking it down in very simple terms. That's it. So this is the first thing. And finding out my value. My value is the t value that I need. Okay. T value is a very simple formula that you have to again remember, or you would be given in the paper. You just have to know when to apply it. So this is the t value formula. Okay. And the third thing is you have to find the borders. So what are the borders? So this, if you remember in the z-test, you just find the borders, you just find the critical value using just alpha. But here, there is a mathematical difference in the background which talks about the entire population and stuff, but we're not getting into that. Here we find the border. Just remember that we find the border using 2 parameters. One is alpha and other is the degree of freedom that we discussed some time back. So you use both of these to find the borders. Now, alpha is 1 minus confidence. So if someone says that I want to say something with 90% confidence, then alpha would be 1 minus 90%. 90% is represented as 0.9. So alpha is 0.1. So that is how alpha is represented, and that is how confidence interval is represented. So these are the three things that you primarily need to find out the entire to test the hypothesis. So your aim is to test the hypothesis here using the t-test. So now we got the alpha value, we got the degree of freedom. How do you find out the critical t value? How do you find out the borders? So that is what you use. You find out from this table. So what the top row says is that area in one tail. So one tail test, two tail test, it is dependent on hypothesis, and Raghu would have discussed this in the video. Just have a look at it. So once you find out using the hypothesis that if it's a one tailed or two tailed test, just select one of them. Okay. So once you get the alpha value, just find the corresponding degree of freedom. Okay, and you map it. So a value in the row, a value in the column will give you one specific cell. So the top two are the alpha values. Okay. It's very similar to the process which is followed in z-test. You just have to map it and find the value. And now what you do here is you compare the t value which is found using the formula, my formula which I had written in the previous slide. I'll come back to it again. And the t value which is found using the table. And it's very simple. You just compare both of them. It's just greater than less than, that's it. So if you find that it is within the acceptable region, your null hypothesis is valid. If it's not, if it's beyond the acceptable region, then you just reject the null hypothesis, saying, okay, it's not in the acceptable region. I won't accept the null hypothesis made. So this is the entire process of a single sample t-test. Now we just go and have a look at an example. Okay, so it's the same example which ma'am discussed in class, which is that which says share price of a company at different days of months. So we have different share prices, and we have to find out if mean share price is different from 65. With a 10% significance. Now, again, we'll just break this problem down. We can see that our first observations is that n is 10. We have 10 elements which are our sample, okay? Starting from 66 to 68, the numbers given. They are 10 numbers. We don't know the population standard deviation. It is not given. We don't know. Sigma is unknown. So given that both of these are there, we can immediately relate to the first table. Just imagine that, remember that we have to use a t-test. Moreover, we just have one company sample data given. So it's one sample t-test. So once one company's one sample is given, so it's a one sample t-test. That's it. So you have zeroed down upon the kind of test that you have to make. Now it's all about the process then. So next, your first step would be defining the hypothesis. It says that I have to find out if mean share price is different from 65. So what I do is I assume, okay, share price is 65. So that will be my null hypothesis. So share price is 65, mu would be 65. That is my H naught. And alternate hypothesis is that I want to check what I want to check. I want to check if mean share price is different. So mean is not 65. That would be my alternate hypothesis. So moving on to the step 2. I just go and calculate the t-value. For calculating the t-value, you just take all the numbers and just dump it, you'll get the value. Okay, so you calculate the mean of all the given numbers, that is x bar, which comes out to 67.5. You find the mean, okay? You find the population mean. That is what you're assuming. You're assuming that it's the mean share price is 65. So your assumption, you're taking it as 65. That is mu. And standard deviation is 2.8. So this is the standard deviation of all the numbers that is given. So 60, all the 10 numbers which are given. Okay. Now, if you don't know how to manually calculate a standard deviation, it's not very tough. You can. There are YouTube videos. I'll probably attach a link in the description. So that is there. And I know that there are 10 elements of the sample. So n is 10. Okay. So I dump all those values and find out the t-value. Next, I have alpha as 0.1 because it's given 10% significance. If it is given 90% confidence, then it means again the alpha value will be 1 because I said it 0.9, 90% is 0.9. So alpha becomes 0.1. And degree of freedom is 9 because I have what 10 numbers and I am finding the average. So there are 9 numbers which can be changed and 1 number which is dependent on all the others. So 9 numbers are free. Degree of freedom is 9. So using the same table that I have shown, which would probably be given to us in exam, we're not supposed to memorize that. So you find that, you find that your critical t value. You find the critical t value, that is 1.833. Now you take that critical t value and plot it on a t graph. So this is basically t graph, which looks very similar to z graph, but yeah, it's even again it's symmetric, but the test video is different. That's it. So you plot it, just plot it on the graph, 1.833 and minus 1.833. Just don't worry that positive negative, because it's symmetric on both sides. It's 1.833 on both the sides. It's a two-tailed test, so you take the value from the table appropriately. And now the calculated t value is 2.82, and if you plot it on the graph again, you find out that it goes into the rejection region. So it says no, it goes into the rejection region. So my conclusion would be very simple. It says null hypothesis that mean share price is ₹65 is wrong, so you reject it. So that is what it says. But what does it actually mean? Okay, so we say that 10% significance, that means 90%. I'm 90% confident. So if I translate it, less than 90% of the times, my mean would be mean of samples would be ₹65. So less than 90% of the time, which is I'm choosing it to be 90%. You can choose it to be 95% also. If you take it 95%, it's again harder to get the number within that region. So less than 90% of the time, it means it's not very frequent. It doesn't happen very frequently. So only if it happens frequently, you can say that mean share price is 65. Okay, it is happening very frequently. So I can say that mean share price is close to 6. No, it does not happen frequently. So your null hypothesis is being rejected. Now the selection of the alpha value is itself a very complicated process. For us, it would be given in the exam, but in real life, again, you have to consider a lot of parameters before taking an appropriate alpha value. So the core meaning behind your conclusion is that less than 90% of the time, your mean value would be 65%. But 65 rupees. But I want most of the time to be 65 rupees. So yeah, it's not suiting my my hypothesis. So I'm rejecting my null hypothesis. So that's how it works. So yeah, I hope you got this. I've tried to make it as simple as possible. Just go and refer Raghu's video also. And there is also a single tail test. Here I've covered a double tail test, but the process is the same. It's just the way how you treat a single tail test and double tail test. You can refer Raghu's video to have an idea of that, because he has explained it. So I've skipped it here. So yeah, that's it. Thank you. Thank you. Bye.